Here we go. Module 3 test review. Relation. So anytime it looks like a discrete relation, we need to make sure that we're putting in the actual points. So we've got 2, 2. We've got 3, 6. We've got 5, 8, and 10. And we've got, what is that, 6, 16. 8, 12. 8, 18. Goodness. And 9, 14. So then we need to do the domain. So we've got 2, 3, 5, 8, 6, 8, 'Why did I do? I know. I messed up on this. This is not 8, 10. It is 5, 8, and 5, 10. There we go. Okay. 5, 6, 8, and 9. Much better. And then we've got 2. We've got 6. We've got 8, 10, 12, 14, 16, 18. Okay. Is it a function? No. Because if I draw a line right here, it goes through more than one point. So that is a no. Is it discrete or continuous? It is discrete, and it is nonlinear. That does not make a line. Okay. A local library was selling some discarded books. Daniel collected books or data to determine the number of books people bought and the price they paid for those books. He let X be the number of books and Y be the number of dollars paid. The relation shown is in mapping. What does the independent variable represent? So independent, remember, is the X. So it is the number of books. Dependent is the Y value. So this is the number. Why is it the number of dollars paid? Paid. There we go. And what is the relation? So we're going to come over here and look at the mapping. So 1 goes to 2. 2 goes to 0. 2 goes to 10. 3 goes to 6. 7 goes to 4. 8 goes to 6. And 9 goes to 4. Okay, is this a function? No. Because if we look at it, 2 has 2 different, and when we're talking about books, it's going to be discrete because you can't have part of a book. Okay, then Amir's average cost of taking a taxi to work has steadily increased over time. The average cost of taking a taxi to work is the blank variable, time is the blank. So Normally, time is going to be your independent variable. And dependent is going to be cost. So let's look at this. It says explain what it represents. So what area 1? So we're talking about volume of air in a balloon, and we're talking about time getting bigger and the amount of air getting bigger. So the air going into a balloon. What is part 2? When you stop blowing up the balloon before you let out air. Okay, and then what does 3 mean? Letting out the air. Okay, so this next one says the table and graph show the number of pounds of bananas sold at the local grocery store from 2013 to 2017. So the x-axis represents, so this down here, what does it represent? It represents the year since 2013. And the scale, 1 year. The y-axis represents the number of pounds. I was going to write sold of bananas. And it has a scale of 10,000 bananas. Okay, find the domain and range of each, and if it needs interval notation, do interval notation. Determine if it's a function. Okay, here we go, the domain. This does not have continuous, so it's not going to have interval notation. Here, -3, 0, 5, 10. Is it a function? Yes. Each input has exactly 1 output. Next one, domain. Oh, this is interesting. I don't know why the numbers are all weird. 4, 5. The range, -1, nope, -2, -1, and 0. You do not need to repeat. Function, yes. There is exactly 1 output for each input. Okay, next, the domain, 0, 2, and 5. Range, -3, 2, and 4. Is it a function? No, because 0 has 2 outputs. This next one, domain, let's see, -6, 4, 5, 6. Range, 2 and 5. Is it? Yes. Each input has exactly 1 output. Okay. Domain. Now see, why did I do that? This is continuous, so it's going to go from here to here. So my lowest number is -1. My highest number is 5, and that's the domain. The range, oh, I should do that in a different color so that you can see. It's going from here to here. So from -3 to +3. Function, yes, it's a function. No, it is not. It fails the vertical line test. This one, domain. So this is going to keep on going all the way this way, and all the way this way. So the domain on this is -infinity to +infinity, or all real numbers. The range, the smallest on this for the range is going to be here. And it's a little less than -2. So I'm going to guess what it is. I'm going to say -2.2. Yours doesn't have to be exactly the same as mine, but it goes up to infinity. Is this a function? It is. It passes the vertical line test. The domain. On this, you can plug in any number you want. So it goes from -infinity to +infinity. This is a line. This line is going to go like this. The range is also going to be -infinity to +infinity. Is it a function? Yes. It passes the vertical line test. Okay, next one. Domain. My lowest number is -2, 0, 8. My range, 0, 3, 7, 9. No, because 8 has two different outputs. Okay, next, the domain on this, 5. The range on this, -1, 2, 4. Is it a function? No. 5 goes to 3 different outputs. Okay, so this next one, use the graph to the right to answer the following questions. Write a story of what this graph might be showing. So we have seconds on the bottom and elevation on the top. Joe needs to hike down a hill. He stands for, what is that? 4 seconds. Goes down at a rate of -4/5 feet per second, then rests for 2 seconds, then goes down at a rate of 1, 2, 3, 4, 2, 3 of negative 4/3 feet. Oh, we're going down. We don't need to write the negative. 4 feet per second. He then needs to go back up. For 2 seconds. Okay, what is the average rate of change in elevation from 10 to 13? From 10 to 13, oh, I just found that a second ago. If I draw this, 1, 2, 3, 4, so negative 4, and it went over 3, so negative 4/3 feet per second. What is the average rate of change from 0 to 15? So if I just did from here to here, what would it have been? So I'm going to draw my triangle. So 1, 2, 3, 4, 5, 6. So negative 6 over 15. So simplify that, negative 2 over 5 feet per second. What is the domain on this? Well, the smallest number on the x-axis was 0. Why am I writing it like that? 0. The highest was 15, or you can write it 0, 15. Both 0 and 15 are included. The lowest range value is 2. The highest is 10. So you can write this either way. Oh, it says to write both of them. Dr. Ambia recorded the names and ages of the patients she treated for influenza today in her office. The names and ages and years are as follows. So what's the domain? Leona, Tomas, Jerry, Melanie, and Bailey. And then my range, 40, we want to go in numerical order. So I've got 32, 38, 45, 52, 61. Is it a function? Yes. Determine whether each relation is a function. Is it discrete, continuous, or neither? Was the domain and range. Oh, I forgot to put, okay. So the domain on this would be 1, 2, 3, 4, negative 4, negative 3, negative 2, negative 1, 1, 2, 3, 4. What is the range on this? The range goes from, it's 2, 4, 6, 8. Is it a function? Yes. Each input has exactly one output. And I forgot the other things. I forgot to discrete. Oh, helps if you know how to spell discrete. And this one is the one that gives domain. Nope. The domain goes from negative infinity to positive infinity. The range, this is the highest it is. So 1, 2, 3, 4, 5, 6. I'm going to say goes from negative infinity to what, 6.5-ish? Is it a function? Yes. Each input has exactly one output. This one, the domain, the smallest that it can be is 0. The highest is positive infinity. The range can go from negative infinity to positive infinity. Is it a function? No. Doesn't pass the vertical line test. Okay, this one, the domain, the smallest, why do I keep doing that? The smallest number it's going to be is -2. The highest it's going to be 2. The range, the smallest it's going to be is why did I do that? -3. The highest it's going to be is 3. No. Fails the vertical line test. Okay, solve this. Okay, so I'm going to replace -9 times 2 plus 8. So that's going to get me -18 plus 8. So that's going to get me -10. So f of 2 equals -10. H, I'm going to replace with -2. Never mind. -12 minus 4, get me h of -2 equals -16. G of x equals 7. So 7 equals -2x plus 3. Subtract 3, get 4 equals -2x. So x equals -2. Okay, g of 3. So that's going to get me -2 times 3 plus 3 minus -2 times 4 plus 3. So this is going to get me -6 plus 3 minus -8 plus 3. So this will get me -3 minus -5. That turns to a plus sign. So that gets me 2. And H. Did I plug that into the right one? I did. Okay, and so this is going to... Nope, I need to do this one. Okay, so F. So -9 times 5 plus 8 minus the quantity, -2 times 1 plus 3. So I get -45 plus 8 minus -2 plus 3 equals -37 minus 1. So that's going to get me -38. And last but not least, -22 equals 6x minus 4. Add 4 to both sides. I get -18 equals 6x. Divide by 6. And get -3 is equal to x. Okay, a company that sells nutrients for the soil uses the graph to show how one of its products releases a nutrient over time. Use the graph to determine the function that models. If the function models this relationship is discrete, continuous, or neither. So this is continuous. Draw on the picture if it has a relative maximum. So right here, this is a relative maximum. And this part right here, that is increasing. And all of this, I should do a different color. All of this right here, that is decreasing. Okay, A number cube labeled 1 through 6 is rolled. The results are recorded in the table. Use the table to determine whether the function that models this relationship is discrete or continuous. It's discrete because you don't have 3.2 and 6.5 or 6.5. You only have whole numbers. Okay, write the linear equation in standard form. Remember, if you have standard form, that it's going to be ax plus by equals c, no fractions, and a is positive. Okay, so first of all, I'm going to get rid of this fraction. So I'm going to multiply everything by 3. So I get, I don't want x to be negative. I'm going to multiply by negative 3. So that's going to get me 2x equals negative 30y plus 6. I'm going to add 30y to the other side. And I get 2x plus 30y equals 6. Okay, over here. Again, I don't want a fraction, so I'm going to multiply everything by 4. 16x minus 48 equals y. The y needs to go on this side, so I have 16x minus y minus 48 equals 0. I need the c to be on the other side, so I'm going to move it. I get 16x minus y equals 48. Is it a linear function? So it has to be y equals mx plus b. The exponents have to be 1. So if I multiply this, I get 6y minus 2xy. Does anything here say xy? Nope, so this is not a linear function. This right here, 2y equals negative x plus 9. And if I divided everything by 2, it would be y equals mx plus b. So it's yes. These are squared, so automatically no. Denominator, that's in the denominator. Remember, that would be y to the negative 1. Can't have negative 1, so no. Well, d is in the denominator, but I can cancel out. So I have d over 5 plus 9 equals 11. I only have 1, and it's an exponent of 1, so yes. Here, look at the graph. What's the x-intercept? I look right here, it is 1, 0. What is the y-intercept? 1, 2, 3, so 0, negative 3. When is this a positive function? So remember, above is positive. So I look at my x-intercept of 1, and it's all the stuff above that. So at 1 and above will be positive. Okay, from here down would be the negative. So from negative infinity to 1, it will be a negative function. In behavior, as the x value increases, I'm going to do a different color. As the x value increases, what does the y value do? It's going increasing also. Increases. As the x value decreases, so as the x value goes this way, the y value is also decreasing. Okay. So, a garden supply store manager found that if he used a certain function, she could determine the price to charge for shovels to maximize the store's revenue. The graph represents the revenue of y of the store if the price per shovel is X dollars. Use the graph to find and interpret the symmetry of the function in the context of the situation. So right here would be my line of symmetry. So X equals $40. What does it mean? When the shovel cost $40, it has the maximum revenue. Okay. The relative maximum is the point 45,000. And basically it means the same thing. Okay, what is the x-intercept here? So that's when y is 0. So -2, 0, and 2, 0. What is the y-intercept? 0, 8. Okay. Football after being kicked. What is the x-intercept? The x-intercept is 5, 0 at 5 seconds. The ball is on the ground. Y-intercept is 0, 6. When kicked, the ball is at 6 meters. What is the relative maximum? It is approximately 9.5. It is when the ball is changing from going up to going down. Okay, what does the origin represent? At 0 seconds, the ball is on the ground. Where is it increasing from 0 to 2, it is increasing, and from 2 to 5, it is decreasing. As the x values increase, the y values decrease. As the x values decrease, the y values decrease. Is it linear or nonlinear? Well, let's see. Goes up by 3. Ouch. Up by 3. Up by 1.5. This did up by 2. Up by 2. Up by 1. So 3 over 2 equals 1.5. 3 over 2 equals 1.5. 1.5 over 1 equals 1.5. It is linear. So the slope I just found is 3 over 2. So f of x equals 3 over 2 x, and the y-intercept would be 15.5. This one, plus 2, plus 4, plus 1, plus 1, plus 1, plus 1, nope, plus 2. So that would be 2, 4, and 1/2. So definitely nonlinear. This one goes down by 1, down by 1, down by 1. This goes up by 1, up by 1, up by 1. So my slope is 1. So, or negative 1. Why did I write negative 1? Negative x. So if it's going down by 1, so if I went back 6, that's going to go, this is plus 6. So here we have to have, so negative 18. If I go back 6 more, that's 0. 6 more, that's negative 24. So this gets me minus 24. Plus 10. Plus 23, 28. Oh, nope, they're going down. Hold on, this one went down instead of up. This one goes down by 12. This is plus 5 minus 14 minus 6. So this is 10 over 5, which is 2. This is negative 28 over negative 14, which is 2. And negative 12 over negative 6, which is 2. So that means that this is linear. And so my equation for this would be f of x equals 2x. And that is going to be minus, let's see, I'm at negative 2, negative 5. If this goes back by 1, by 2, that means this has to go plus 2. So that's going to be negative 3 plus 2. That's going to be negative 1, so minus 1. This over here, this is going down or up by 18. This is going down by 3. This is going up by 24. This is going down by 5. Up by, nope, down by 4. This is going down by 4. So that would be 18 over 5. Negative 3 over nope, not linear. So then this one, remember we're going to move it to the left. So that would get me 3x minus 3 is equal to f of x. If I solve this, I would have gotten 3x equals 3, so x equals 1, but we have to graph it. So I get to negative 3, 1, 2, 3. I go up 3 and over 1, up 3 over 1, and I draw a line. This one, again, if I move it to one side, or to the left-hand side, that will get me negative 11 is equal to f of x. We'll go by, I don't know, 2, 4, 6, 8, 10. I guess we could go by, we'll go by 2s. And it will just be here. Okay, and then it is no solution. This one, if I move everything over here, I get 15x minus 15 is equal to f of x. I do not know why I did that. So if I solved it, I would get 15x equals 15. I would get, again, x equals 1. So if I did this by 5, 10, so negative 5, negative 10. Oops, I don't know why I did that. So that's not really going to help. How about I do 3s, negative 3, negative 6, negative 9, negative 12, negative 15. goes there. Okay, and then this one, climbing. Indira is mountain climbing and starts the day at 182.5 meters above sea level. Each hour she descends, that means she goes down, 36.5 meters. The table shows the function of Indira's height to the number of hours she is mountain climbing. Find the intercepts. So the x-intercept is 50. The y-intercept is 0, 182.5. 0, 182.5 means she starts at 182.5 meters, and 50 means after 5 hours she is at 0 meters, or the bottom.